Now what we are going to do is we are going to first look at the image. We'll see how MATLAB can read these images, and then we'll use a for loop to read all the images at once and then take the average of that. Okay, so to read the image, let's say I have a new variable called subject, and to read, the MATLAB command is niftiread because I want to read Nifti files. And now here I have to give the path of that particular image that I want to read. Now let's say I read the first image. So if you see directory, or if you see the output of directory files, it has a lot of things. It has name, it has folder, date, etc. So first I'll have to create the path using this directory. How I do that is, there's a function called full file which needs parts of file that are there. Let me just type it and then maybe it'll be clear. So let's say files, which is our directory, which is output of the directory, and I want to access the first image. So that's the one over here, to access the first image, and then give it the folder first. So that's the folder location of this particular first image, and the name. So what will happen is when I execute files of one.folder, it'll give me the folder corresponding to the first image, and when I give files of one.name, it'll give me the name corresponding to the first image. And full file will combine both of these and give a complete path of the image. So that's how I can get the complete path of the image to niftiread, and niftiread can read the subject, read that particular image. Okay, so when I do this, you can see subject variable is created over here. You can see that it is a 3D matrix. That means it has 3 dimensions because our MRI image is 3D. And you see the data type, it's int 16. Okay, I'm focusing on data types a lot. Spoiler for something that's coming up. Okay, so that's our image. Now how can we view this image in MATLAB? So let's say there's something called orthosliceviewer. So the orthosliceviewer is another function inbuilt in MATLAB which will show you the image. Okay, it takes some time. Okay, so that's the image in MATLAB. Now usually we don't see MRI images like this because usually when we see MRI images, this direction, so over here this is the axial image, which is this view, top view. This is the coronal image, which is in some sense a front view, and this is the sagittal, which is this side view. So what we usually do is we consider this as the x-axis, this as the y-axis, and this as the z-axis. So orthosliceviewer is not built for that. So let's just do some manipulation to orthosliceviewer so that we get something that usually neuroscientists or radiologists deal with. So this will also give you some idea of what is called as figure handles in MATLAB. So now what I've done over here is I have written h is equal to something. So h is going to be our figure handle to orthosliceviewer figure. let me just execute this and it'll be more clear. So when I do this, again you get the figure, but then along with that you get a H orthosliceviewer object over here. Okay, so once you have this particular object, what you can do is you can manipulate the axis in the figure. So you can get the axis as follows. So let's say, let me just type this out and then it'll be more clear. So there's a function called getAxis handles. Yeah. So there's a function called getAxis handles, which will give me the axis control from the figure object that is already created. That's the H. So when I do this, I get 3 more. So these are called axis. So axis is basically these over here. So it gives me the control of these axes in a particular figure. Now that I have axis, I can rotate these as I want. So what I do is so there's a command called view, and what I want to do is I want to rotate this image as follows. And when I do that, oh, there's one more thing. So that wasn't what I was expecting. So another thing in orthosliceviewer is the way it reads the 3 dimensions is also different. So you need to first permute. Permute is like transpose. I'm changing the dimensions. So like when you do let's say you have a matrix called A, which is 1 2 3 4 5 6, and you can do A transpose. So when you do A transpose, what you're doing is you are changing the first dimension and the second dimension. So first dimension initially was 1 2 3, but now the first dimension is 1 4. You see that? So it's like rotation. Now permute does the same thing but for 3D objects. So if your 3D object, it's like a cube, transpose does not actually mean anything, because transpose only means something for 2D matrix. So the 3D equivalent of transpose is permute, and you have to tell it how do you want to change the dimensions. So you change it as, I want the third dimension first, I want the first dimension second, and the second dimension last. And when you do this, this is how we usually see or we view the images. So now writing all of this again and again is kind of, again, hard or not good, and it is better to be lazy. So what you can do is now you can actually create a user defined function. So let's say I create a new script and I create a new function, which is, so this is my function, and let's say I'm going to, so you just put your things that you want. So let's say I want the function's output to be H, and it'll be my orthoslice viewer. Okay, so I'm going to change orthosliceviewer such that it is what I want it to be, and what I actually want is I want it to read the subject, get the edge, that is the axis handle, and rotate it such that it is always in the view that I want it to be. So now I can save this particular thing, and notice the script name will be the same as that of the function name, and you can save it. Once you do that, what will happen is you can just comment out this and just basically say my orthosliceviewer subject. Now anytime you execute this, it will automatically change the views and all of that and give you the image that you require. So this is an example of function. You can use this for creating any user defined function you want. So that's how we also learn how to create functions in MATLAB. Yeah, so that's how you can view MRI image in 3D in MATLAB. So that's a 3D plot. So once that is done, let's see how, let's say we just want to deal with some slices, and we don't want to see the image in 3D but just a slice of the image. So then people usually use what is called imagesc, again a MATLAB function. So imagesc requires a two-dimensional matrix. So let's say subject. Now subject is a three-dimensional matrix. You can see, excuse me, you can see it here. Now let's say I just give it one particular slice. So let's say, so this image is 61 cross 73 cross 61. Let me just give it one of the middle slices, which is, let's say, 30, and let's see what it does. So when I do this, notice it is giving me an axial slice of the image. Now the problem is, I mean, not in some sense problem, but the way it is showing you is colored image. It is showing you blue, yellow, all these things, right? So this is what to do with color maps. So this is what is called the default color map of MATLAB, called Parula. You can press this particular thing to see the values. So any value that is 0, let's say, is shown in this particular color, which is like dark blue or purple, and anything which is 3 into 10 raised to 4 is yellow. That's this. But let's say you don't want to see these colors, you want to actually see grayscale or something like that. You want to see a grayscale image. So for that, the command is color map. So when you do color map, there are, so the default is Parula, which I just told you, but then there are a lot of color maps that you can choose from, and if you choose gray, it will give you the grayscale image that you want. Oh wait, so that's your grayscale color map. So I've given you a list of different color maps that are there in MATLAB. So these are predefined color maps in MATLAB. You can just type these names and you get the corresponding color map. So this is better if, I mean, this is good if you want to, you know, work with figures and all of those stuff. Okay, yeah. So that's about reading, plotting all the images. Now I showed you an axial slice. You could also see another view of that if you change the dimension. Oh, this will give you an error. So this gives you an error because So image SC only expects two-dimensional image and three-dimensional color image. I'll not go into that now. So basically two-dimensional image. But when you do this, what MATLAB returns is again a three-dimensional image with the middle dimension as 1. So it's like 61 cross 1 cross 61. This is again a three-dimensional thing. So what you have to do is there's another function called squeeze. Squeeze basically squeezes anything that is one dimension, and now it will work. So this is the coronal slice, the mid coronal slice. It's like this one. Yeah. And if you, let's say, put the number in the first dimension, you will get a sagittal slice. Yeah, so that's a sagittal slice. Oh, one more thing. You see the image is stretched. It's like stretched like this. So that's also not a good thing to view, right? Because your images are like they're squishing and stretching out. So to avoid this, what you can do is, again, you can use axis and tell it to be the image. So this will maintain the aspect ratio. And now if you do this, it won't squeeze or stretch. It'll maintain the aspect ratio that you want.